All right, for example 2, in section 3.1, I am going to walk you through how to get that data into your TI-83 or 84 calculator. Again, if you're using a different calculator, that's fine, but you'll need to Google your instructions for how to do the things it is that we need to do. So what I'm going to have you do with your TI-83 or 84, the first thing you're going to do is find the stat button. Okay, it should be, if you look at the little arrow keys, it should be just to the left of the left arrow. It says stat right on it. You're going to press that, and then you're going to select number 1, which is edit. Okay, and you can either press the number 1, or since it's already highlighted, you can hit enter, whichever you want. Then what you're going to do is enter the data into L1, which should be list number 1. Okay. If, by the way, you need to clear any data, so let's say you have some in there to clear data, you will arrow up to the list name, whichever one you want, L1, L2, etc. Okay, so when you're there, then you will hit clear, which is right below the arrow keys, and then you'll hit enter, and it will clear out any values that are in there. All right, and so whether or not you need that now or whether you need it in 10 minutes, you're going to need that information. Okay, so arrow up and highlight the list name, L1, L2, etc. Hit clear, don't hit delete. Okay, hit clear, and then hit enter. All right, so back to stat 1 edit. So once your the first entry in that list is highlighted, then you're going to enter the data one value at a time, hitting enter between each one. Okay, so go ahead, pause the video for a second and take some time to enter in that data, and then I'll tell you what to do from there. Okay, hopefully by now your data has been entered. So once you've got those values in, I'm going to go ahead and have you hit the stat button again. And then I'm going to have you use the arrow button to arrow over to where it says calc for calculate. Okay, and then the very first thing you see should say 1 var stats. Okay, for one variable statistics. Sorry, that's supposed to be a T there. Stats. It doesn't look like it. One variable stats. Hit enter. Okay, and then if you have a newer model calculator, it's going to say list, and you should see L1 or wherever it is you put your data. Okay, hopefully you put your data in L1. When it says frequency list, don't worry about that. Just arrow down to calculate. Okay, so where it says list, you need the name of your list. So name where you put data, where data is. Okay, and then arrow down to calculate and press enter. Okay, and it's going to put up a bunch of information for you, and we're going to talk a little bit about what that information is. Now, in this particular question, the first thing it says is find the mean. Okay, find the mean. I do want to point out one thing. Okay, the mean is the mean, whether it's a population or a sample. The calculation is done the same way. Add up all the values, divide by the total number. The symbol that you need to use depends on whether you're talking about a population or a sample. Okay, is it X bar or are we going to use mu? Now in your calculator, the first thing you should see is an X bar. Your calculator will always tell you X bar because your calculator does not know if that list of values is the exhaustive list because it's a population, or if it's a partial list because it's a sample. Okay, your calculator doesn't know, so it always gives you X bar. You have to use the wording in the question to determine which symbol you need to write down on your paper or type into the computer, as the case may be. Okay, so this says a local cafe with a small menu has its nutritional values of all its foods. That word all is really important. That tells you that we are dealing with a population. Okay, so that means for the mean, we don't want to use the symbol x bar, we want to use the symbol mu. Now, with this data, everything is to the nearest whole number. So when we look at our data here, and we're going to round to 1 decimal place, and so the mean should be 6.4, and we are talking about 6.4 grams of sugar. Okay, now for the median, again, capital E or capital M, sorry, or MED, you don't have to go to great lengths to say, like, really, I'm going to have to put those in order. Just going to wait for Peterson to do it on the other end of the video. No, no, no. Your calculator's already done it for you. If you arrow down on that same screen you're looking at, you will see MED equals, and it will tell you 3 grams of sugar. So it has found the median for you, which is really nice, especially when it comes to larger sets of data. And then the last one is the mode. Sorry to tell you, your calculator will not find the mode for you, but all you need to do again is look for the value that appears most often, and in this case that would be 0 grams of sugar. Okay, so we've found the median, the mean, the mean, the median, and the mode. We labeled each using correct notation. So the last thing we need to do is interpret the measures of center. All right, so on average, what are we going to say? So on average, the items have, and then how much sugar. Now, I certainly wouldn't say no sugar. That's kind of a, I mean, yeah, it's the most common, but that's only 3 out of 21 that have no sugar. So using the median and the mean, those are kind of somewhat far apart in terms of grams of sugar, and it's okay to include both of those in your summary. So on average, the items have, I would say, 3 to 6 grams of sugar. And just leave it that way. Let people know that there's a range of values. Okay. All right. This next group should go here pretty darn quick, so just find the modes for each of the following. So for A, notice that there is no value that appears more than once, so we say that there is no mode in that case. For B, obviously the 5 appears twice, so the mode is 5. In this second one, we have a tie. There are 2 2s and there are 2 5s, and so there are 2 modes. 2 and 5 are both the modes. And then in this last one, it's a mode is not just about who has more than one, it's about who has the most. Okay, there is a winner here. 5 is the winner, so 5 is the mode. Okay, just to make sure we go over a few of those basics again. And then at the bottom of this page, and you're going to use this information quite a bit as well. So this is a test about how the data is shaped. Remember, we talked about symmetrical and skewed to the right and skewed to the left and stuff like that. And I said we're not just going to look at it in terms of the pictures of the data, but we're going to be able to use other values to be able to tell us what the data is shaped like, even if we don't have the data set. Well, here's where this comes into play, at least for the first time in the course. Okay, so if the mean is equal to the median, okay, if they happen to be equal, then the data is symmetrical, okay, and the mean is the most appropriate measure of center. Okay, so if they are exactly equal, you will use the mean. I know they're exactly equal. You could say, well, why can't I use the median? I guess technically you could. They're exactly the same, but from a statistical standpoint, we will use the term mean. Okay, if the mean and the median are close, okay, approximately equal, they're close, but they're not identical, then the data set is approximately symmetrical, and the mean, again, is the most appropriate measure of center. Okay, so they're close, not quite. Okay, you're going to use the mean. That's the one you're going to use to report. If the mean happens to be larger than the median, then your data is skewed to the right, and the median will be the most appropriate measure of center. Okay, if the mean is greater than the median, the data set is skewed to the right, and the median will be the most appropriate measure of center. Let me give you an example, okay? If you think of the average salary of, people working at a bank, all right, the tellers and so forth. And then you throw in the bank president or the bank CEO. You throw in their salary into the mix. The mean is going to go way up because the bank president and the bank CEO make way more money than those tellers do. Okay, so the mean would be higher than the median, the middle salary, which is going to be the salary of a teller. Okay, lots more tellers than there are presidents and CEOs. So what that does is that would say, like, suddenly all those tellers, maybe making $40,000 a year. Now it says their average salary is like, 300,000. No, not really. Okay. So skewed to the right, we've got some really high values that are pulling that mean up, but we're going to report the median as the appropriate measure of center. Similarly, on the other end of the spectrum, if the mean is less than the median, the data set is skewed to the left, and once again, the median will be the most appropriate measure of center. So same philosophy in a different order. So let's say this time we're talking about test scores, okay? And the tests were, again, pretty darn good, but maybe there were 3 or 4 people that didn't take it and they got zeros. Well, what's that going to do to the mean test score? Okay, well, if everybody else got 70 and higher, and then I throw in some zeros, my mean is going to be dragged downward. Okay, those zeros are going to make the rest of the class look really, really bad. And so in that case, again, our data is skewed to the left. We've got a handful of low values. We would want to report the median as the average, okay, the typical score, because we don't want the dinglings that didn't take the test, right, to impact what's going on in terms of the whole set of the class. And if you've got more questions about that, let me know. I would be happy to talk to you about it, or you can actually just play with some data sets of your own, okay? Those are some of the best ways to do it. Make some data and put in some really high values and see what happens to the mean and see what happens to the median when you do, okay? And same thing on the low end.